Lesson 1.4 is the beginning of geometric proofs. For a lot of kids, proofs are the hardest thing in geometry. So we're going to start out basic and we're going to build on that. Everything we do from 1.4, it's going to fluctuate. Some things will be easy, some things will be difficult. It's just going to go up and down. So be ready. So 1.4, we're going to go over just a couple things in 1.4. We're going to start. It is just logical reasoning. So it's deductive and inductive reasoning. So let's look at this. When points on a circle are connected, the line segments divide the circle into some number of parts or regions. So if there's one point here, and then like now there's two, so notice there's two parts. And these connect, and it creates sections, 1 section, 2 sections, 4, and then 8. You are trying to discuss, like basically, we're finding patterns. Why does this happen? What's going to happen with it? I'm not going to give answers, but let's look at this next part. Use inductive reasoning to extend the pattern. So here are these random numbers here on this example 1. I'm going to pick a color, and I'm trying to figure out how you got from 88 to 82. Now, right away in my head, I'm like, oh, well, you subtract 6. So I'm going to say minus 6 and write that as a pattern. You might have done this in Algebra 1. And then I'm going to see if that same pattern is true the next step. 82 to get to 76. Yep, subtract 6. I'm like, ooh, I think I'm getting it. So minus 6. And then again, minus 6. So it looks like we've got our pattern, but make sure to test all of them. Yes, minus 6. I can't even fit it over here. Minus 6. So it looks like that's our pattern, and I'm going to go to my solution. Yep, minus 6, and there it is. This is a lot nicer and organized than my terrible writing, but then it asks you to get the next few numbers in the series, so there they are. Okay, so let's go to this next part. I'm going to erase this. Try to see if you can see the pattern here. Okay, I'm going to try addition or subtraction first. So I go 8 to 3. Oh, sorry, that's a B. Just kidding. I go 3 to 5. From 3 to 5, I'm going to say, okay, I add 2. And then from 5 to 9, I don't add 2 anymore. So I'm like, oh, great. In this case, I add 4, so I'm going to say plus 4. So I'm like, 2, 4, not really seeing a pattern yet. And then 9 to 15, I'm adding 6. You might see the pattern. 15 to get to 23, I'm adding 8. So 2, 4, 6, 8, what is the pattern? What are you noticing? And then the solution is under here, of course. And so you try to figure out what the pattern is using that deductive reasoning. It might not always be addition or subtraction, so you need to be aware of that, but find the pattern, whatever it is, and try to explain it and extend the pattern. Okay, here's some more. In math, we do a lot of conjectures. A conjecture is exactly the same thing as in science, a hypothesis. So it's an educated guess based on what you have. So if I look here, conjecture, and it even says it's an unproven statement or rule based on inductive reasoning. It's your guess or hypothesis. So here we have 2 dots, but it's term number 1. So it does have 1 row. So there's 1. Here's term 2, and this one does have 2 rows. Here's term 3, like the third one, and it has 3 rows. So term 4 should have 4 rows, which it does. So I figured out that the rows keep increasing. So 1, 2, and then 3, and then 4 is the exact same number as the term, but it's not the same number as the dots. So then you would have to figure out that, like, how does the first term relate to 2 dots? Or the second term relate to 6 total dots? It might have to do with the columns, the rows, any kind of pattern. So you're going to try to figure that out. I'm going to go to the next one. Make a conjecture or prediction or hypothesis. And you're going to do this same idea as the numbers. And we made the little arrows and stuff. Try to see the pattern between the total residents and the voters. Okay? And I'm trying to get to a specific example. Counterexample. So this conjecture talks about counterexamples. A counterexample is just that. It is an example that doesn't work. So counter example, it shows something that is false. So it's going to ask you for a couple of counter examples to show something is false. And then we're going to make a big jump. We're going to go all the way down to the summary. Go through these summaries. Make sure you get the idea. We're not worried about every step and every pattern. We're worried about the big picture. So do you understand how to find patterns and what to do with those and how to get the next set in the pattern? We're going to skip do you understand this time. And then we're going to go do you know how. So on the do you know how, try to do these, I believe, 3 different questions. Okay, and that's 1.4.